We are going to discuss about fiber reinforced composite. Okay. At first, we are going to see about the introduction about the fiber reinforced composite. Fiber reinforced composites are a class of composite materials in which fibers such as glass, carbon, or aramid are embedded within a matrix material. Okay, the fiber provide the composite the strength and stiffness while the matrix binds the fiber together and helps transfer flows between them. Okay, here we have two types, the structure of fiber reinforced composites. Okay, first one is the fiber and the second one is the matrix. Okay, in fiber there are typical long thin filaments that provides high strength and stiffness. Okay, this type of fibers used in carbon, glass, okay, like this. And the matrix material surrounds and bind the fibers, holding them in place and distributing the applied loads. Okay, but generally it's using in high performance, for example, aerospace, automotive, and constructions. Next one is the elastic behavior under longitudinal loading, right? The longitudinal loading refers to apply a force in the direction parallel to the fiber in the composite. Okay, this is often considered the primary loading direction, where the fibers are aligned with the direction of the applied load. Okay, the longitudinal modulus of elasticity is measure the stiffness of the composite when subjected to loading along the fiber direction, right? This fiber are aligned the direction of the applied force, and loading is applied along the fiber direction. So the matrix plays the less significant role in arresting the longitudinal loads compared to the fiber. Here we want to discuss about some of the stress strain behavior in longitudinal loading, right? Here the stress strains are generally proportional until the material reaches its elastic limit. Okay, here the composite materials have a higher stiffness than the matrix alone due to the strength and the stiffness of the reinforcing fibers. Okay, the fiber carry the majority of the load, and matrix material deforms less. Okay, acting uh, primarily to transfer the load between the fibers. Strength, the tensile strength of the composite in the longitudinal direction is also governed by the properties of the reinforcing fiber. The strength of the composite is generally much higher in the longitudinal direction than in other directions. Okay. Next, going to discuss elastic behavior under transfer loading. Okay, transverse loading refers to apply the force perpendicular to the direction of the fiber. In this case, the matrix plays a major significant role in the fibers are not aligned with the applied load. Okay. Here, the sustained behavior of elastic elastic behavior under transverse loading is the sustained relationship is more linear for lower loads, but the composite is much less uh, stiff than in the longitudinal direction. Okay, due to the low stiffness, the matrix and the limited load carrying capacity of the fiber. in the direction to composite can undergo significant deformation under transverse loading. Okay, this strength of composite under transverse loading is typically governed by the matrix material. Okay, thank you.